Hi, and welcome back to this week's episode of the Structural Engineering Podcast with Max and Zach.
Zach, do you know what episode number this is?
We are at episode 50.
Can you believe it? I remember when we started this, we listened to the first one we recorded and we said, that really sucked, but I bet you by 50, we'll be okay at this. Do you think we got there?
I think we've gotten there in certain parts. I think we can probably still just always be better at making our edits even cooler. I think our content's getting better. I don't know about you, but I'm enjoying it more than I ever thought I would.
Oh, absolutely. I tell you what, by 100, I have a feeling that we're going to be pretty good at this.
I hope we're exponentially getting better.
That's right. Well, we got a cool episode this week. This week we talk with Annie Kao, the Vice President of Engineering at Simpson Strong-Tie. She brings insight for both an engineering and management perspective.
During the episode, we discussed the culture of Simpson Strong-Tie, why Toyota is important, and how to be a successful engineer.
Now, let's get into the episode.
Hi, I'm Annie Kao. I'm the Vice President of Engineering at Simpson Strong-Tie.
Thank you very much for joining us. To get us started, everyone in the construction industry has heard of Simpson, and I think you're most known for wood connectors. When you're talking to someone outside the construction world, how do you describe Simpson?
When someone asks me about Simpson, I just, meet somebody and they're just not familiar. What I like to say is that we are a construction solutions company. So we were founded in 1956 by this extraordinary human being named Barclay Simpson, who was this big idea person, but he was also someone who knew how to get things done. And so there's this classic story of how Simpson started, about how Barclay and his family owned a window screen company. So they had this machinery that was able to, just bend sheet metal. So he had a neighbor who was working on building a kind of like a warehouse building and realized that he had to have all of these metal pieces to connect the 2x4 roofing. He knew Barclay had this machine. He knocked on his door, one Sunday evening, I think is how the story goes, and was like, hey, Barclay, can you make me, something to connect, the end of this 2x4? And so, Barclay fiddled around with the machine and came out with kind of the first joist hanger. And that was really the beginning of the realization that there were all of these connections that needed to be made in buildings, and that using, metal connectors made a lot of sense. And then having quality metal connections really came through as it came to the realization that obviously building codes and jurisdiction requirements, that these were really critical connections that needed to be engineered and, triple checked.
That's so cool. Is this the very first metal connector then, or was there anything used in construction beforehand?
I think it was, we like to say that it was one of the first ones, but I think just in the industry that there were kind of different iterations of connections. I mean, toe nailing was very prevalent, back in the day. And so I think where our claim to fame is probably that we had one of the first tested metal connectors, and really just was able to get solutions in the marketplace for wood construction that over time and over our history has really expanded into just different areas of construction. So we have a lot of heritage, I would say, in the wood construction area, but we also have a long history now for, post-installed concrete. We have a lot of connections when it comes to structural steel and cold form steel for exterior connections. We have a whole line of structural fasteners. And so we're really extended just to, where is it that we can bring value for these engineered, tested connections that people need to have higher performance and really just easier to install. So that's been our kind of heritage, and our legacy is just coming up with these engineered solutions that just make things better.
Cool.
So to carry on with that, how many fields would you say Simpson has, such as traditional wood, concrete, mass timber? What else is there?
Yeah, so wood for sure. And even when we look at wood, we think about how it fits into like the residential market. So we look at, and even then that's really varied because there's single family homes, there's multifamily. You see that there's kind of more of your builder type, right? Where you have tract homes, where you just have a few models, but then you're trying to, hundreds or thousands of the same kind of model. So there's that. There's concrete for sure. And then within concrete, we look at commercial construction, right? So your office buildings and your car dealerships, your hotels, if you will. There's like industrial type, right? So you have wastewater, you have nuclear power plants. You have then infrastructure, right, with roads and bridges. You have kind of what you mentioned, mass timber, kind of cutting edge technology where how can you build some of these same things but with different materials. We look at, I mentioned infrastructure, so there's like, airports, there's was just trying to think. There's like seawalls. There are wood pilings that you have for piers. So we talk a lot about just concrete restoration. We talk about concrete repair. There are just so many different markets that you can look at. There's like agricultural. You look at silo grains.
Yeah. Is there
So there's
anything
just
you're
a
like
lot.
not in or purposefully, something, a sector that of the building world that you don't touch?
Yeah, we tried to be really strategic. We've tried to really think about like, where is it where you can have a product that's engineered that's going to add value? So there's one, I'm trying to think of one. So you look at like nails, commodity nails. Simpson really doesn't have, we actually sell nails. We'll sell buckets of nails if you look at like a home center, like a Home Depot or a Lowe's, but it's not like an engineered one. And so we have some of those kinds of things, but in general, anything that you would consider a commodity type project that's not really load rated, but maybe has to meet like an ASTM, that's where you won't really see Simpson, because that's not where we've really built our reputation on. Where you see us is kind of in this high performance type of products, where it's designed, where it's engineered, where it's being specified.
I'm curious, do you know how many buildings Simpson has a product in like the world or the US?
Yeah, that's a really good question. I mean, predominantly our business is in North America, although we are global. So someone had made the comment the other day that they felt like some absurdly high percentage of homes in the U.S. have some kind of Simpson product in them. Yeah. I don't know what that would be, but I don't know if it would be so crazy to think that it would be in the high, in the 90 percentile of homes that would have some kind of Simpson product in them. I mean, the residential market obviously is just one, part of the entire construction.
But that's most of the buildings in the, in the U.S. Mostly their houses.
That's true. So I don't have a good sense, but at least in the residential market, I would think if you have a building, if you have a house that doesn't have a Simpson product in it, it would probably be pretty rare.
Yeah, that's pretty cool.
How do new products come to fruition? And with that, is there a specific process Simpson uses to facilitate these continued developments?
That's a great question. How does a connector product or a Simpson product come to be? And there are a lot of different avenues for it. And where it typically starts is with an idea out in the field. So one of the things that we just pride ourselves on is just the amount of field support that we're able to offer, to the industry and to our customers. And that takes its shape in a bunch of different ways. So we have sales field representatives, but we actually have a huge team of what we call field engineers and branch engineers. And so these are folks with their, professional engineering licenses that have probably done a number of years with like a traditional structural engineering consulting firm, who are now going out and being a resource. And so they get to hear all the stories. So not only do they get to hear the stories, they get to see what we sometimes call just inventive uses of Simpson products and other products on the job site, because people are really trying to figure out how to get things built and how to put them together. And that feedback that we get from contractors, other engineers, other trade inspectors, just, even architects, it's like, well, God, it would be so great if we could do something this way. It'd be so great if we could eliminate this week of construction time, if we could just have this framed before this. And so that kind of feedback we are just continuously seeking out. And it's really, I want to say, it's part of our culture, it's part of our DNA to always be listening to the customer. So kind of going back to Barclay Simpson, who I mentioned earlier. So we build our company culture around something we call Bark's 9 principles, his 9 principles of doing business. And the number one principle is relentless customer focus. And so we are always thinking about what can we do better to address what's needed, right? And that's where these product ideas come from. And so I'm trying to think of an example. So we have our HDU hold down. I don't know if you gentlemen are familiar with that. So it's a hold down that you put on the end of the shear wall, you install it with screws. So this came about in the 90s. So in 94 was the Northridge earthquake, right, in Los Angeles. You had all of these hold downs that were bolted. So if you have a bolted hold down, you have to drill a hole in the wood post, right? Tends to be oversized. You put that in, and in an earthquake, when you have a bolt hole that's too big, you get too much movement. And when you have that on the end of the shear wall, shear wall drift is so critical. Once your hold down can be as strong as you want, but if you have too much movement there, then your wall moves too much and you get these building, failures that we saw in the earthquake. And so it was like, Well, we can't have that. What can you do? How can you eliminate that source of shear wall deflection? So it's like, oh, well, if you put a screw in instead of a bolt, then suddenly that what is that? That delta sub something that's part of the shear wall drift equation that's out of my mind now because I haven't done design here in a little bit.
Just a quick pause from speaking with Annie. What she's talking about there is the shear wall deflection calculation. This is in the NDS. It is equation 4.3-1. The shear wall deflection is based on the bending, the shear, and the wall anchorage slip. Within the wall anchorage slip portion of the equation, there's a delta sub A. The delta sub A is a factor of which you can find in the Simpson catalog per each hold down. Now back to the episode.
You drastically reduce that. And so you just have a solution that's in place. And that came directly out of, what we were seeing from building performance. And so that's just one example of thousands of different products that we come out with that is really just in response to what we're seeing out in the field.
That's awesome. How long does it take when you get a direct kind of a question comes in to get a product either change or a new product into the market?
Yeah, I like to ask that question myself sometimes because it's a very iterative, iterative process. And as we were saying before, we have so many different kind of product lines at Simpson. We have our fasteners, like I mentioned. A fastener tends to have a shorter turnaround time than if you're developing a new lateral system, right? Like a new prefabricated shear wall or a new moment frame. But if you're talking about like a connector, right? Kind of going back to our heritage and legacy. So if you're looking at a connector, you're probably looking at about a year to a year and a half time frame from from idea, if you will, to being able to introduce something to the market. And when you look at all those steps, you can imagine we get a lot of ideas. The idea funnel is pretty wide, and part of it is actually going through and trying to decide which ones make sense to move forward on. There are market studies. There are what we call just ROIC, which is return on invested capital. Just looking at how large of an opportunity is it? How big of an impact would it be? Where could you use it? Who would find it useful? And so we try to do a lot of that work up front so that when we come out with something, it would be something that's useful to a number of people instead of being just one thing that one person asked for at one time, which we have a different process that we can address if it's just a modification of something as opposed to launching a whole new solution.
How do you know something has made the cut when you're finished with the product?
Another great question. So the way that we know if something makes the cut is we have some really great people who work at Simpson with a lot of years of experience. We have people who used to be contractors. We have people who used to be framers. We have, engineers who came from the industry, and we have just a great network of folks that we like to run ideas by. And so it's a lot of different factors. And we're actually going through that process right now. So this kind of late summer, early fall is when we start thinking about planning, business planning for the next year. And so what we really look at is, how do we want to grow as a company, and what is it that we're hearing from the industry that is needed to kind of move us to the next level, right? So we talk about mass timber, we're talking about CLT and offsite construction, we're talking about concrete repair and being able to have solutions to address buildings that are 40, 50 years old, right? That you don't want to tear down, but you want to be able to repair in place. We look international as well because, in North America, you build with wood. The rest of the world builds with concrete and steel. Yeah. And so how are we able to address just the changing landscape of where we're doing business and what we're hearing in terms of, trends in the industry and how people are wanting to improve their processes?
Is the development process mostly completed in-house, or do you work with universities and contractors and other fields to test and develop new ideas? Yeah,
so our process is, I think, a healthy mix of both, because I think what we always want to try to do is make sure that we're not tunnel visioned and that we know what we can do and what we want to accomplish and not taking into account, outside. So we try to actually work as much as possible with outside partners. So we work a lot with industry associations. So when you think about just all of the structural engineers associations, as well as all of the building official associations, building inspectors, Academia is such a huge partner for us, and I think this is really reflected in different partnerships we have with Washington State University, Cal Poly San Luis Obispo. We work with University of Miami, Virginia Tech, Colorado School of Mines. I mean, there's actually such a long list of universities that we make sure that we're in touch with, because that's really where the new ideas are coming from. And the partnership I see is, Simpson being, an industry manufacturer, we're looking to see how we can take those ideas and turn them into something that folks can use on job sites, and kind of getting that transition from a really great research project to how can you make it into something that you can actually manufacture on a greater scale and make it, cost effective to do. That's kind of the neat part, I think, of what we're able to do with Simpson, is put some of that logistics and practicality to cool ideas that we see coming out of universities and PhD programs.
So with older products, are they intentionally revised and updated? And how does Simpson approach improving existing systems?
Yeah, older products. We call it the obsoleting process, when we try to take a look at what things are just retired. I mean, anyone who has looked into product development, right, even outside of Simpson, and it's something I really recommend to engineers, is just understanding just the business part, right, of how decisions are made. And it was something that I had learned at Simpson, because that was one of the cool things I had learned at Simpson when I started out here as what's called a branch engineer, just someone who was helping out at a regional level, because it really helps to explain why things are available sometimes and not other times. And so when you look at a product development cycle, you have, kind of the inception, and then you have this peak, right, when you have, really high use, and then you have this, I forget what the official term is, but I think of it as the retirement phase, right, where it's kind of past its useful lifespan, and it's time to kind of transition to new products. And so that's something that we look at all the time. It's a term we use called product rationalization, where we don't really want to have 5,000 different hangers, right? We want to have maybe 1,000 hangers that are really the best, right? They're easiest to install. They cost the least to manufacture. They're, have the highest load rating. And if we have products that don't kind of fit that category anymore, we want to go ahead and sunset those. But with how the building cycle works, right, you can design a project that doesn't go into construction for a year or 2 years or 3, depending on the scale of things. It makes it tricky to kind of rationalize or obsolete a project. And so that's something we work really closely with distributors who sell our products, as well as the specifiers, so calling them out in the plans, to really try to build a healthy amount of awareness anytime that we are retiring a product, because we know that just because we're retiring it doesn't mean that it's not going to show up on a set of project plans and can introduce some confusion there. So it's a constant process for us. I would say the last 5 years or so, we've really tried to make a concerted effort to retire things and help direct specifiers and contractors to just the better solution. But again, because of that building cycle, it just takes time to roll through. And so that's another thing I like to ask of the younger engineers, is that just encouraging that effort that it takes to update typical details and just awareness of better products, because it takes time and effort that no one I know has in their day-to-day when you're just trying to complete projects. But it really pays dividends in the end, because you just have a better building design as a result.
Absolutely. I love it. That's something we've pushed a lot, is like pushing back on typical details that have been around for 20 years, just giving them a revisit and making sure they're still as they should be. So you mentioned talking in the past that Simpson tries to follow lean manufacturing procedures, principles. Could you tell us a little bit about what that means?
Yeah, so Simpson is, at our heart, we're a manufacturing company. I guess I would argue with that. Sometimes I like to say we're an engineering company that just happens to manufacture. Sometimes it's a manufacturing company that has a lot of engineering. But manufacturing is such a huge part of what we do. And so we're always trying to be best practices when it comes to there. And so anyone who's ever looked into manufacturing knows that Toyota is this, they're just the gold, platinum, diamond standard when it comes to introducing better processes. And so maybe about 10 years ago, I first got introduced to this concept of lean manufacturing, which is when you have a manufacturing process, you try to eliminate any step that doesn't add value, right? If someone has to pick up a widget at one station, walk across the building to give that widget to another person, let's move that station so that they're right next to each other. And then you've just eliminated, that was like 5 minutes of one person's day, but you take 5 minutes times 10 people times your 200 working days of the year. And suddenly you're like, oh, this is something where if I repeat that and I do that across my entire process, suddenly I'm so much better. And if anyone's interested, you just look into what Toyota did for the manufacturing of cars, and it just blows your mind as to how much room for improvement that there was in that process. And so that's something that we've done quite a bit at Simpson. And once I started learning about this on the manufacturing side, there are lean principles that you can apply in the office setting, right? So all these lessons that you can learn from the shop floor, bring it to an office setting, and it's almost as simple as not everything needs to be a big change, but if you make all of these little changes, suddenly you realize that over time, it has added up to this huge improvement. So there's this term called Kaizen that was introduced by Toyota.
Hey guys, just wanted to jump in real quick. Throughout the episode, you'll hear Annie talk about Kaizen and lean manufacturing. If you want to learn more about the philosophy, check out the book, The Toyota Way to Lean Leadership by Jeffrey Liker. It's linked down below in the show notes. Now back to the episode.
It's these two Japanese characters that actually stand for change better. So it actually, the real interpretation probably stands for like continuous improvement. And you think there's such an effect of continuous improvement on manufacturing. What would that mean if I introduce that into my own workflow, right, as an engineer? Mm-hmm. And so I think like, I should do things like, so I used to travel a lot and visit different engineering offices. So I'd have my laptop and my mouse and all my cords and stuff. So every time I would set up, to do a presentation, I would like pull out my jumble of stuff from my bag and spend 5 minutes like plugging in my power cable and doing all that and having that. And so like one small thing is like, why don't I just get those Velcro loops? So every time I put my things away, I put it in my Velcro loops. And suddenly when I go to another place to set it up, I am just organized and it just flows. And I'm not like fumbling, because that would make me kind of feel all flustered and, and it would just put me off on this bad foot every single time I would meet a new office. And so that kind of silly change, right? Just getting these Velcro loops actually helped set the whole stage for going in and, talking to an engineering office. And so I started talking about this as I was going into different offices, and I was like, where's the opportunity then for engineers to introduce these small changes that can make real impact on their workflow? And so one of the things we've started to do at Simpson is like, how can we kind of put together these little, we call them web apps, right? These little web apps that can help just make it easier to find the information, right? Just the data access. So everyone knows the Simpson catalog, right? Everyone gets a copy. It's like, I don't know what it is now. We're at like almost 400 pages on the Simpson catalog. And of those 400 pages, like 100 of them are hangers, right? Mm-hmm. So I know when I was in design, I would flip through, I'd be like, all right, I need a 6x8, face mount that installs with screws. So I'd flip through and I'd find it and I was like, okay. And I need it to be able to resist at least like 6,000 pounds. And I would go through the tables. I'm like, okay. And I have a roof application and I'm in high seismic design category. And then I would find the right column and find the number, right? Call it a 4 or 5 minute exercise. So we have an application, a web app called Joist Hanger Selector that's on our website, strongtie.com. And so you go to Joist Hanger Selector and you can put that in. I can say what my header is. I can put in what my joist is. I can put in what my load demand is. And then it will come up with me a list of the 5 hangers that'll work for that application. And then my favorite part is it tells me which hanger is the lowest to install in terms of cost.
Oh, cool.
And so as a designer, I can just get the information I need by using a tool that's available. And we have about 25 of these web apps for different applications. And I know other companies do as well. And so I just really encourage engineers, like, look for and use the tools that are available out there. And yes, there's that little bit of a learning curve that it takes just to familiarize yourself with what's available and what tools are. But man, I mean, if you're saving 5 minutes every time, and that's something that you do like 10 times a week, and you start to add it up, you're like, oh, that's
It
it's
becomes
like a little
something.
thing, yeah, that can make a big difference.
Make a comment. I think it's really cool, like you just said, that it also it also tells them what the most cost-effective option is. Because I think as engineers, we don't have the best connection with cost as we were designing. We go, okay, this hanger works. Well, there could be another hanger that works that's half the price, but we never know. We just see it in the catalog, pick it, and have someone build it. So I think it's really cool that there's a price built into that.
Yeah, this whole idea of value engineering, right? And I totally came up against this when I was first starting out. Like, you just don't have a frame of reference. Like, I have no idea that a HD19 costs, I don't even know, 10 times as much as a HDU5, right? They both do the same thing, right? They're both hold downs. They both get me at least 5,000 pounds of uplift. But one is just a better product than the other for that application. And so just having that awareness. And so that's just another thing that I love about Simpson, is that we have our test lab that is literally right next door to our R&D department. And so we have this ability to not only kind of think of and dream and design and model a part, but then we can walk, the 100 feet over to our test lab, get it installed, see how it is, put some lumber in there, put some screws in, and actually see how, is it actually a better solution than what we had before? So as much as I can encourage engineers to get out there on the field, get their hands dirty, put product in their hand, try to put themselves in the shoes, of the installer to really figure out, what's the best way to detail something.
That's so cool. So you mentioned you have, 25 web apps. I know you have some sort of desktop apps as well. Could you give us like an overview of all of the technology available, the resources available to the designers?
Yeah, we only have limited time here, right? I'm so excited when it comes to talking about technology, because just within our engineering department, like how we can use technology, how we can develop it, has been such a core focus for us over the past few years. And so, web apps is just one part of it. Another part, like you said, is, like desktop software, right? What are these engines that we have to actually be able to run designs? We have two big ones that I can think of. So one is our Anchor Designer software, which is all about post-installed anchors. The cool thing about the software is not only does it do post-installed anchors that are like proprietary, like, Simpson mechanical anchors and adhesive anchors, but it also does cast in place as well. So it's really trying to be a tool that engineers will find useful, outside of just the product. So Anchor Designer does cracked concrete design, in accordance with ACI 318. It has, I think, one of the best outputs of Anchor design software, because it actually delineates exactly which section it's checking and designing, and what the, whether or not the capacity fits in there. And so it's just a very detailed output that I think is useful to both specifiers and for plan checkers to make sure that it's all in accordance. And there's some really cool features coming out in future builds that, again, as we were saying, input that we've gotten from the field as to what would be useful to be able to have, customize your anchor output, to be able to design the base plate, the same time as the anchor. So those are features that we've incorporated from feedback from the designer world. The other big piece of software that we have is called CFS Designer for cold form steel design.
Yeah. It's
to be able to do the traditionally, it's for both load-bearing and non-load-bearing applications for cold form steel. I used to specialize in the cold form steel area, so I get very excited talking about this. So whether you're trying to build a house out of cold form steel, or whether you're trying to put that exterior, skin on a larger commercial building, that's what that software is set up to do. So it's all dialed into AISI requirements. It helps you check, the out of plane and the in plane bending. If you're doing stacking shear walls, you can do up to like 8 stories of shear wall design in there. And so it's a really cool tool that you can tap into. And just, again, if this is spreadsheets that people were using before, if it was like a calc that they would just photocopy and then like white out the numbers, this is what I use. It's already set up, so I can just white it out and then put in the new numbers and then photocopy it again. It's kind of an all-in-one design suite that is just so powerful if you're doing a lot of cold form steel design, or actually on the flip side, a lot of engineers I talk to only do the occasional cold form steel design project and kind of have to relearn it a little bit every time because they're like, oh, what did I do on that project last year, that one time? The software just enables you to have all of the building code requirements built in, as well as kind of take you step by step on what the important bits of information are. So those two I would just really recommend as great tools for engineers to utilize.
Awesome. I know a lot of the ones you have are free. Are all of them free? How do you decide which goes into what bucket?
Yeah, it's the economics of it, right?
Yeah.
So Anchor Designer is a completely free software. CFS Designer for cold form steel, that is software that we actually sell a license for. Although depending on the office, I would say in terms of the investment for a software like that, that it typically tends to make a lot of sense for engineering offices just for the capabilities of it. And I would say if anyone is interested, to reach out to your regional Simpson, either salesperson or even better, your field engineer, because they can give you a much better insight. And I think we have a free demo of it available as well if anyone wants to check it out and see if it's something that would make sense for their office.
So I have a question. This is more my issues with wood. So I think wood can be tough for some companies, consultants to streamline. Just, compared to concrete and steel, the load path ends up being a little more complicated. There's obviously a lot of connections. Mm-hmm. Do any design programs have integrated Simpson connections to kind of streamline and maybe schedule some of these items?
Yeah, you're asking a very timely question, because we were just talking about how to make our information more readily available to what we consider like third-party software, right? Just building design software, or just any database that really wants to call Simpson information. And so I know Simpson products actually do show up in different software. So there is some seismic design software called SP3 that our moment frames are featured in. So I'm just thinking like Ram Steel is another third-party software that we have integrated our new YieldLink moment frame connection into. What we do on the Simpson side is there is a way of programs talking to other programs called APIs. Mm-hmm. Is this a term? This is something I've just learned recently. I was like, oh, okay. So it's like these kind of active databases, right? Where if you need to know all of the Simpson hangers and all the load values and all the dimensions, and you need to know the most accurate information, we have a method through something called an API that can talk to other software and basically provide that information. What that means is that there are just different ways to tap into Simpson catalog information, right? That is just using these new technology tools, these new technology channels to be able to do. And so what the vision for that is to be able to interact with just more software packages, right? That offer things like whole house design or, just other design capabilities, and be able to have that Simpson module, if you will, or just the Simpson information integrated into it. And really it's information that we want to make available to whatever software package, would find that useful.
That's excellent. And one more technology question for you. We have some contractors that listen to the show. For the contractors, is there a specific software package that you would recommend they take a look at?
Oh, that's a great question. We have some web apps that I think are very contractor focused, and actually, we have found that some of our most popular web apps tend to be the ones that are that have that audience in mind. And so we have something called Adhesive Cartridge Estimator. So if you have a job and you've got 500 3/4-inch diameter holes that are 6 inches deep, like how many tubes of Set 3G, right, or Set XP or whatever adhesive it is, do I need to have that in there? And so the Adhesive Cartridge Estimator helps you do that. And it takes into account things like, well, how oversized is your hole, right? Like what temperature are you installing it in? And so there are, I want to say, a handful of apps that we have that are contractor focused. I think the contractor tools that we have that are probably the most useful are like installation videos. Mm-hmm. We have a ton of content on our YouTube channel, which I think our username is Strong-Tie. And so if you go on there, it's just, not only job site videos, but just animations and just trying to help make sure that the installation is as straightforward and as easy as possible. And by just, I watch YouTube videos for everything, right? I was trying to change the little flapper on the inside of my toilet the other day, and I hadn't done it before. I was like, oh, I just watched the YouTube video, and suddenly I'm the world's expert on how to change, toilet flappers. And so we're really trying to tap into all these different channels, especially in this, COVID day and age where going to a job site or going in person is not as not accessible as it used to be. So not only YouTube, but Instagram videos, right? LinkedIn videos, and really trying to produce a lot of content that would be useful for on-site folks.
Okay, so now kind of jumping away a little bit from the technology side, and more of what you personally think. So if anyone listening is interested in structural engineering, but doesn't think the consulting necessarily will be the right fit for them, what is working at Simpson like, and who is it a good fit for?
This was like a conversation I had with myself after working in structural engineering for a structural engineering firm. I guess I'm going to rewind a little bit. So when I first started, I went to school, I got my bachelor's degree in engineering, I got my master's in structural engineering, and I was like, I'm going to go and I'm going to work for a structural engineering design firm. So I did that for a number of years, and I loved the firm. I worked for a firm out of Southern California. But I realized that what I had really loved about the job and what I loved the most was going to the job sites, working with the architects, solving the problems, and just trying to figure out how I could spend more of my time in that arena that I just had this passion for. And I looked around, and it struck me that there was this whole area that I hadn't thought of, which was going into the kind of the manufacturer side of things and being able to be a resource to structural engineering offices. Because I knew that I just found a lot of value having the structural engineering knowledge, and I was just wanting to apply it in a different way. And so I would just encourage anyone who's thinking about that, right? Because, the structural engineering design path is such a great fit for so many people. So folks who just see themselves as wanting to be that senior engineer, right? And having that technical knowledge, or wanting to move and be the principal of their own firm, right? And really getting and developing their business knowledge that way. That is such a great path for folks to go down, but it's not going to be the right path for everyone. And so what I love is that within structural engineering, you have this ability to get into, these different channels that still tie you in to the ultimate product, right? Which is building, which is helping to design a building, but being able to apply just different talents and different points of view into there. And so what I would tell somebody who is in design and maybe doesn't feel that that is the long-term future for them is that there is so many different avenues. So I have friends who have gone into construction management. I've had people I know who have gone and to be like a building owner's representative, right? I have people who have gone and worked for general contractors. I have obviously people I know who have gone into manufacturers. There are, industry associations, who always need liaisons. There are just so many different channels to look at and consider before you think that, structural engineering is just not the place for you, because there's so many ways to be a structural engineer, I think, in this day and age.
Absolutely. That's fantastic. So, continuing that on that a little bit, and since you've certainly worked with a lot of structural engineers, being at Simpson, you get to see how a lot of people operate. What do you think makes a good structural engineer? And I know we're kind of throwing this one on you, so you can.
Yeah, I say this to so many of your questions, but that is a great question. What makes a good structural engineer? And that for me has really changed over the years as I've thought about it. And from where I've stood now, and I've had the chance to visit hundreds, if not maybe thousands of different engineering offices in my time out in the field. And for me, what it's come down to is like a really good structural engineer has a lot of empathy. Like that empathy being just this understanding of what their client needs, and then also what their team needs to be successful. And the best structural engineers that I have seen have this way of listening and understanding to a problem and then trying to apply a solution for it. We joke about how, at our Simpson engineering department, like as soon as we hear something, like we want to list off like all the ways, right, that you can fix that problem, right? Like, oh, you can't do that. Well, here's this, and this. And what you sometimes miss is it's a sales term. It's like, well, what's the need behind the need, right? Someone tells you like, I need a new fastener, but turns out they're not really saying that. They're saying, I need to do this connection better, right? Or I need to be able to connect from one side of the wall because I can't access the other one because it's an existing building. And so the more that you listen and the more opportunities that you take to kind of find out as much information as you can and understand kind of the actual problem, that's where I see these superstar engineers, right? Because then they come up with a solution that is just so well suited for the problem that they're up against. And the best engineers are the ones that have the best relationships with their clients. And I see those are the engineers that get, referred, to other, building owners or to other large institutions, because people just love working with them because of how well they're able to address and deliver a solution to whatever's needed.
I think that's a great answer. It's definitely in an engineer's nature, when a problem is presented, they're like, here's the solution, here you go. Or like,
yes.
This is the answer to what you said.
Yes.
And digging a little deeper definitely gets you in a better relationship and maybe finds the root of the problem and can solve it different ways. But
it's a tough one though, because when you're in school, right? Like you're given a problem, you do the solution. I mean, that's the that you're in. And then I think you get into the real world and you realize, it's not as cut and dry as you think, right? I mean, there's this joke, right? You give one problem to 10 engineers and you'll get like 10 different solutions, right? So there's this art to it, and there's this real finesse to being able to come up with something that's a solution, but it's just a better solution, right? And it's just being able to address something in a way that is technically really profound, but also really playing into the importance of that relationship with the client.
I really enjoyed your last answer there. I think that really is a good way to sum up a good structural engineer. I think sometimes it's hard to come up with the words of that person that's really good, but I think that right there really makes sense to me.
I think it's been interesting for me. So I've been in my role here at Simpson for about a year now, and it's my first time actually having a team as large as we do here. So just to give you a sense of scale, in North America, Simpson has about 140 engineers, and overseas we probably add another 200, 215 to that number. And so when I think about how do I help develop, our larger team to just, continuously improve, right? We go back to this whole idea of lean manufacturing and just continuous improvement and making sure. I mean, we think a lot about how do we, personally develop people, right? And help them develop, what you typically call the soft skills, right? Just the communication skills, the conflict management, like negotiation, like all of these things that we don't really spend a lot of time on as engineers, right? Coming out of school, because, we're really valued for our technical expertise. But then you figure out like the way that I communicate that technical expertise, the way that I'm able to show people that this solution is the best one becomes so much more valuable kind of the more and more you progress in your careers, because now people are just going to assume that the technical excellence is there. Mm-hmm. What they really want to know is that what you're suggesting is really the best way. And so as much as I can encourage, your listeners to really spend as much time, developing those skills in their career as they do on the technical side, I want to do that, because I have just seen that has, again, been a big differentiator between folks being successful, in their careers, and other folks just feeling like they've kind of hit a wall.
That's excellent advice. Does Simpson actively do training for this sort of thing? That's part of the program when you're working there?
We do. Yeah. We invest quite a bit in our employees. And we have a program actually called Strong Leaders. And so it's a whole program that you are involved with over a series of years, actually, to help you kind of build foundational skills and kind of moving up, right? Building skills to be the managers, because we look at our, younger generation as our future managers. And so I want to be able to put skills and classes in place for them to make sure that, in 5 years, 10 years, whatever that ramp is for someone to get there, that they've been learning that the whole time. And it's not that they have to learn it like on the job once they, get that manager or supervisor position. Mm-hmm. So it's huge. It's something that I was a huge beneficiary of, through my time at Simpson. And so as much as folks can seek that out, and I know smaller engineering firms just don't have the capacity, right, to have that. And so as much as you can seek that out for me, getting involved with the Structural Engineers Association, for me, it was the Southern California chapter. I mean, that was where I got opportunities to serve on committees, help organize events, help, have input on strategic vision. There's so much opportunity to get involved and get that leadership experience through industry associations and industry associations are always looking for more members to participate because that just kind of increases the richness of the experience. So if you're somebody who's not already involved, I would just encourage people to see exactly, where they can do that, because there's so much immense, not only professional value, but personal value that you can get from that participation.
That's fantastic.
And I have so much advice. I want to tell young engineers of the world, make sure you do these things. These are all things that I wish I had known, starting out, that I just kind of picked up along the way.
Yeah, I think it'll be much appreciated advice. So, appreciate you sharing that and for joining us on the show this week. It's been a real blast.
Yeah, it was a pleasure. Thank you so much for inviting me.
Hey guys, thanks again for listening to the episode. Let us know if you have any questions by reaching out to us on LinkedIn, Facebook, Instagram, or email. You can also find these links and more information about the specific episode in the show notes below. Have a great week.